like to speak to you a little bit about chemical bonding. Chemical bonding is very important for us as chemists and as science students. So we're going to start off by thinking about what is a bond. A bond is a force of attraction that happens between two or more objects. It can be between people, but for our purposes, we're thinking about on a molecular level. So, a chemical bond is a force of attraction that occurs between atoms or between ions. There are three types of chemical bonds, but for this year, what we're going to be focusing on are ionic bonds and covalent bonds. Those are the two types we look at for this year. All right? Now, if we're going to look at chemical bonding, we need to know the types of bonds and we need to know why do elements bond. All elements that are in groups 1 through to 7 will participate in some type of bonding. And the reason those elements are going to bond is because they want to gain a full outer shell. They want to gain a full valence shell, just like the noble gases. The reason for this is that the noble gases are stable. All right? They want the stability that the noble gases have. So some elements will participate in ionic bonding, other elements will participate in covalent bonding. But once elements are bonding together, the reason they are doing that is because at the end of the day, they want to end up with a full valence shell. They want to be stable, just like the noble gases. Now, ionic bonding, for me, I think is the simplest type of bonding. Ionic bonding takes place between metal atoms and non-metal atoms. Okay, so if you think about your first 20 elements, that simplified periodic table that you guys have in your books, all right, there are 7 metal atoms within the first 20 elements: lithium, beryllium, sodium, magnesium, aluminum, potassium, and calcium. Those are your 7 metal atoms. All the other 13 elements are non-metals. Some of those 13 are noble gases. Some of those 13 are group 4 elements like carbon and silicon. But 7 out of the first 20 elements are metals and all the rest are non-metals. Group 4 elements do not participate in ionic bonding. So carbon and silicon do not participate in ionic bonding. Noble gases do not participate in ionic bonding. So that means elements that are in groups 5, 6, and 7 are the ones that are going to participate in ionic bonding. Now, what happens during ionic bonding? During ionic bonding, the metal atom is going to give its valence electrons to the non-metal atom. The metal atom will give its valence electrons away so that it gains a full outer shell. And likewise, the non-metal atom will also accept its electrons so that it can gain a full outer shell as well. When we learned how to draw atoms, we learned that in every single atom, there is an equal number of protons and electrons. Protons are positively charged, the electrons are negatively charged. So if you have a metal atom and it's bonding with a non-metal atom, if the metal loses electrons, that means that the number of protons and electrons is no longer equal. If you're losing electrons, that means the number of protons is no more than the number of electrons. Think about it. If you have 3 protons and 3 electrons, and you give 1 electron away, now you have 3 protons and 2 electrons. So the number of protons is more than the number of electrons. When this happens, we form a positive ion because the overall species that is formed is positively charged. So, when metal atoms lose electrons and give them to non-metal atoms, we form positive ions or cations. In nonmetals, they also start out having an equal number of protons and electrons. So they start out having an equal number of positive things and negative things. When the nonmetal gains electrons, or when the nonmetal accepts electrons, now you have more electrons than protons. Now you have more negative things than positive things. Think about it. If you start out having 9 protons and 9 electrons, and then you gain an extra electron, now you will have 9 protons and 10 electrons. If you have more electrons than protons, that means you have more negative things than positive things. So the overall species that is formed is negative. The overall charge on the species that is formed is negative, and this is called an anion. So when nonmetal atoms gain electrons from metal atoms, they form a negatively charged ion, and that negatively charged ion is called an anion. Let's look at an example of what happens during ionic bonding. If we consider the bonding between lithium and fluorine, our lithium atom has 1 electron on its valence shell. Now, the EC for lithium is 2, 1. The electronic configuration is 2, 1. And if it were to, let me cover this one up with my cursor. If we were to lose that 1 electron, then it would have a full shell. It would have a full valence shell because it would only have 1 shell, and that 1 shell will have 2 electrons. So lithium wants to lose this electron that it has, but it can't just throw the electron in the trash. It can't just throw away the electron. Can't wipe its feet and get rid of it. The electron has to go somewhere. So lithium is bonding with another element, and that element wants to get an electron. So you have to find an element that wants to receive that electron. Fluorine wants an electron. Look at fluorine. It has an EC of 2, 7. And if it gets 1 more electron, then its second shell will end up with 8, and that will make its shell be full. So lithium will give the electron to fluorine, and when that happens, lithium forms a positive ion, and that positive ion has an EC of 2, and fluorine accepts the electron. This is the electron right there, and now it forms a negative ion. And look at the EC for that negative ion. The EC is 2, 8. Now, one of the things I want you to appreciate and to understand is that you have a lithium atom bonding with a fluorine atom. When the lithium atom loses an electron, it forms a lithium ion. And when the fluorine atom loses its electron, it also forms an ion. Whenever we do any illustrating of bonding, specifically ionic bonding, when we draw elements bonding, we have to also draw the ions that are formed. If we were to only do this part up here and we don't draw the ions that are formed, our work is incomplete. Okay, so we have to make sure for every single atom that is participating in the bonding, we have to also draw the ions that are formed. Okay, so this is the bonding between lithium and fluorine. Lithium gives an electron to fluorine. Why? Because lithium wants to lose one. Fluorine gladly accepts because fluorine wants to gain one, and they end up forming a ionic compound. All right, this is the positive lithium ion. Positive ions are called cations, and this is the negative fluorine ion. This is our anion. Now, in the first example with lithium and fluorine, lithium only wanted to lose one electron. But what happens if we have an element that has more than one electron on its valence shell that needs to be lost? In ionic bonding, our metal atoms can lose 1, 2, or 3 valence electrons. And the nonmetals that will participate in ionic bonding are going to want to gain 1, 2, or 3 valence electrons. So remember that. Hold on to that. Think about that when we start to work through our examples as well. Now, in this example, magnesium has 2 valence electrons. Alright, now it wants to get rid of those 2 valence electrons. Let me cover them up with my cursor. And when it gets rid of those 2, then it will have an EC of 2,8. So, it has to find something, magnesium has to find something that is willing to accept those 2 electrons. In this case, the element that is willing to accept them is oxygen. And oxygen needs 2 valence electrons as well. Because right now oxygen has an EC of 2,6. And if it gains those 2 electrons, then the EC will become 2,8. So again, electron is transferred from magnesium to oxygen. Other electron transferred from magnesium to oxygen. Now you have a magnesium atom and it lost electrons to form a magnesium ion. Okay, and likewise you have an oxygen atom and down here you have formed an ion. Okay, now the magnesium lost electrons, so that means there are more protons than electrons. Question you need to ask yourself is, how many electrons did I lose? I lost 2. That means that if I lost 2 electrons, I have 2 more positives than negatives. That's why my charge on the ion is positive 2. For oxygen, I gained some electrons. How many electrons did you gain? Here they are right here. You gained 2 electrons. How many more electrons than protons do you have now? You have 2 more electrons than protons. So your charge is going to be negative 2. Let's look at another example. Let's illustrate the bonding sodium and fluorine. So let's look at the bonding between sodium and fluorine. Alright, sodium has an EC of 2A1. So if we work out the number of subatomic particles, we'll have 11 protons, 11 electrons, because the atomic number is 11. And then our number of neutrons is going to be 23 minus 11, that's 12. Alright, by working out the number of subatomic particles, that will also help you to figure out what the charge is going to be. So let's draw the structure for sodium. In our nucleus, we have our 11 protons and our 12 neutrons. And the first shell, we're going to have 2 electrons. And our next shell, we're going to have 8. And then on our valence shell, we're going to have 1 electron. Okay, so that's our sodium atom taken care of. Now, let's look at our fluorine. Fluorine will have an EC of 2,7. And in a fluorine atom, we know our atomic number is 9, so that means we'll have 9 protons, 9 electrons, and the number of neutrons is 19 minus 9, that is 10. Alright, so this is our subatomic particles for fluorine. So let's draw our fluorine atom. Draw a nucleus with our 9 protons and our 10 neutrons. On our first shell, we have 2 valence electrons. Sorry, not 2 valence electrons, 2 electrons. And then on our second shell, we have our 7 electrons. So the question becomes, what needs to happen to sodium in order for it to gain a full outer shell? Well, sodium needs to lose this 1 electron that it has here. And what needs to happen to fluorine in order for it to gain a full outer shell? Well, fluorine needs to gain 1 more electron. So what will happen is that this electron from sodium is going to go over to the fluorine. Now, there's a very common mistake that is made, which is to put the electron in right there. But that is very incorrect. You cannot be in 2 places at the same time. So, you're not going to put the electron onto the shell of the nonmetal atom yet. What you're going to do is you're going to draw your arrow to show that this is where your electron is going. Then you're going to draw your ions. How do you draw your ions? Your ions go in square brackets with the charge outside of the bracket. So let's start off with sodium. Sodium had 11 protons, and before it had 11 electrons. Then it lost 1. So now it has 10 electrons. So we have 1 more positive than negative. We have 1 more proton than electron. So the charge is going to be positive 1. But just like in algebra, just like in math, we don't necessarily have to write the 1 because the plus means positive and the positive means positive 1. So this is our sodium ion. Alright, so this is your sodium ion. Every single ion must have a charge. Alright? Once you've drawn the sodium ion, you have to also draw the fluoride ion or the fluorine ion. You cannot draw one ion and not draw the other. Okay, so in fluorine, you had 9 protons, and before you also had 9 electrons. Right? You had 9 protons, 9 electrons. Now, you gained an extra electron from sodium. So now you no longer have 9 electrons. Now you have 10 electrons. So you have one more negative thing than positive thing. So your overall charge is going to be minus 1 to be specific. But again, we don't need to write minus 1 like that. We can just write minus. And now is when we can show that we have received an electron from sodium by putting it onto the valence shell of fluorine and showing that this is where the electron has gone. So this is how we would illustrate the bonding between sodium and fluorine. Alright, we start out with our sodium and our fluorine atoms. Start out with our atoms. Make sure we draw our atom structure correctly. Then we show the transfer of electron. If it's a case where you have an atom with multiple electrons, then each electron will get its own arrow. And then after you show the transfer of electrons, then you're going to draw your ions. Each atom must get its own ion. So there's one sodium atom, there's a sodium ion. And the ions must have charges. There's a fluorine atom, so it must have its own corresponding ion. Okay? I hope this helps a lot, Form 3.